This project is like a sprint, but on a distance of a marathon. It has to move very fast, but all the time.
We are in urgency. We need to go fast, and CO2M is part of this Copernicus program who is helping for that.
Today, Europe is at the forefront of greenhouse gas monitoring. The Copernicus CO2M mission will represent a step change to current capabilities, and people are actually eagerly awaiting its data.
The technology incorporated into the CO2M represent an exceptional fusion of the state-of-the-art, cutting-edge advancement and flight-proven systems.
This mission started with the publication of the CO2 report by the European Commission with the request to implement an operational mission for CO2 monitoring. My name is Jaska Meijer and I'm the CO2M mission scientist responsible for the requirements of the CO2 monitoring mission. The CO2M mission will support the enhanced transparency framework of the Paris Agreement with independent measurements.
CO2M will be the first ever to enable monitoring of human-made greenhouse gas emissions with a system directly supporting policymakers with actionable information.
CO2M will help them to meet their commitments as specified in their nationally determined contributions of the Paris Agreement. The Paris Agreement is about global mean temperatures. This does not imply that the increase is everywhere the same. In the Arctic, for example, we already see that temperatures are rising much faster. Today, since pre-industrial times, we have increased our CO2 levels by 50%. Methane levels are generally lower, but they have also increased and it's a much stronger greenhouse gas. So what does that mean? Imagine that you're already wearing a jacket and now on top you put an extra jacket, which is the increased CO2. On top of this, replace your underwear, made of cotton maybe, with something made out of wool, which is the increased methane. Do you already start to feel too warm? This is exactly what is happening in the atmosphere, with increased CO2 and methane levels.
The current CO2 concentration in an atmospheric layer is around 410 parts per million, and it has been increasing at an average rate of about 2 to 3 parts per million per year. Measuring anthropogenic CO2 emission on a global scale using satellite technology is a very difficult task due to the relatively small proportion of man-made emission compared to the vast and constantly changing background level of CO2 in the atmosphere, which is a part of the natural carbon cycle.
CO2M will support independent emission estimates by focusing on plumes of power plants, cities and nations. The Paris Agreement is actually relying on self-reporting. So we were looking at what we call bottom-up. So nations look at activity, how many cars are driving around, how many fossil fuel went into the country and is burned. For methane, it's the same. So we rely on companies to report their own leaks, and they're not very good at it. So what we see from space is actually much more.
NO2 is co-emitted with a high-temperature combustion processes, and this is a sign that the detected CO2 plumes can be actually attributed to industrial emission. What is key to the Copernicus CO2M observation method is the ability of measuring simultaneously CO2 and NO2 emissions. Hi, I'm Valérie Fernandez. I'm the project manager of this very extraordinary mission, CO2M. Copernicus CO2M will be equipped with 3 instruments which will work together to provide spectral signature on CO2, carbon, CH4, methane, and NO2, the nitrogenous dioxide.
CO2M will therefore help to better estimate CO2 exactly above those areas heavily loaded with aerosols.
Copernicus CO2M technology is unique. The instruments on board of CO2M satellite has target precision of the XCO2 observation of fraction of particle per million in a total column measurement. This creates the possibility to detect CO2, but also to have a knowledge of the changes in the CO2 concentrations as small as 0.5 to 0.7 part per million. It is important to have such high precision in XCO2 observation because even small changes in the concentration of CO2 in the atmosphere can have a significant impact on climate and the environment. This is important to stress that satellite Earth observations is not the only way to measure point sources CO2 emission. We still are going to rely also on ground measurements and different model data. But this is the only way to measure atmospheric carbon dioxide at a high resolution systematically all around the world.
One important element to get precise measurement is to have statistics and repeatability. This requires to have data taken regularly.
We aim to have 2 satellites in the Copernicus CO2M constellation, which will allow us to detect and estimate anthropogenic carbon emission anywhere in the world at a pace of 5 days when crossing equator and every 2 to 3 days anywhere in Europe. With the option of a 3rd satellite in the constellation, the CO2 emission will be passing over European latitude on a nearly daily basis. This means that for the cloud-free part of the path, we will be able to collect data on the emission every single day.
In order to see at the same time the bigger picture as well as the zoomed-in version, we need a relatively wide swath instrument with high spatial resolution.
A key feature of the CO2M is that it is able to detect within one swath of 250 kilometers in one go plumes of CO2M thanks to the simultaneous and collocated measurement of NO2.
To put it into perspective, CO2M will be able to cover the country of the size of the United Kingdom in just one satellite of a path. This kind of combination of swath and resolution is way beyond what is currently possible with any other carbon satellite.
One needs to realize that CO2M has to measure changes of few particles per millions coming from the human-made activities on top of an overall CO2 concentration of about 400 particles per millions. Good morning, I'm Yannick Durand. I am the payload manager in the CO2M mission. 3 instruments are working together to achieve this unprecedented accuracy. The main one is a spectrometer, which detects CO2, as well as 1 cloud imager and 1 polarimeter to correct the measurements from the perturbation induced by aerosols.
Spectrometry imagery is the well-known observational technique that has been used for decades from ground and space to define the atmospheric composition or monitor trace gases evolution.
The instrument to measure the CO2 is an optical instrument, so-called a spectrometer imager. The instrument receives the sunlight after it travels through the atmosphere and is reflected from the ground surface. In this path, the CO2 molecules absorb certain wavelengths of the sunlight. The key technology is to build an optical component which can spread the different wavelengths of this light so to detect the absorption lines of CO2. The principle is very close to the one of a prism which creates a rainbow. Another essential aspect of the improved accuracy of the CO2 estimate is the fact that the MAP instrument will provide a precise estimate of the aerosol. Without this knowledge, the precision in the CO2 estimate rapidly decreases when the level of aerosol increases. Usually, areas with a large amount of aerosols tend also to correspond to areas with a high level of human emissions of greenhouse gases. As always, with optical instruments, detectors are a key technology. And because we are here in an optical lab, there is here a detector that can show, and here it is. So it is an infrared detector, so it is there to capture the light in the infrared domains. And what you can see is that the prism I was talking about is sending the light on the area of the detector, which is the small square in the middle of the detector. The small dimension of 2 centimeters on this side is representing light coming from a swath on ground of 250 kilometers. And the prism sends the light in wavelengths all across the other direction of the detectors. Second, an image of 250 kilometers on the Earth spread spectrally, so all the colors are in this direction, and this is repeated every 0.3 seconds. Finally, in the instrument, there is for the first time an optical component called a two-dimension slit homogenizer, which has a key role in reducing the sensibility of the measurement to the different ground surface reflection. The most challenging aspect of CO2M is to be able to meet the rendezvous with the Global Stocktake.
These assessments are done every 5 years, and the first Global Stocktake is at the end of 2023.
By measuring emissions systematically and globally, we will be able to compare results for numerous countries worldwide. This is a major requirement for the mission to fulfill the global international environmental agenda. Europe has taken a significant leap in the planning and execution of crucial carbon-observing missions.
The Copernicus CO2M mission will be the first operational constellation of satellites monitoring greenhouse gases, and as such allowing to build an operational service based on its continuous data flow.
Copernicus CO2M data will be collected and assimilated by EUMETSAT, the European Organization for the Exploitation of Meteorological Satellites, the well-established partner of ESA for all operational weather space missions, and by the European Centre for Medium-Range Weather Forecasts, or ECMWF, which is developing a dedicated new CO2M monitoring and verification support capacity for Europe. It will combine satellite observation with computer models, enabling us to precisely pinpoint which component of CO2 emission results from human activity.
Working in the Copernicus program on the Sentinel missions makes me feel that my job contributes to the overall awareness of the critical environmental situation in which the world is, and at the same time to provide the tools to cure it.
It's a fabulous combination to push forward the technology development of the next generation missions.
Today, Europe is at the forefront of greenhouse gas monitoring. The whole world is coming to us, and Copernicus is ready to support them.
We will be there, and CO2M should be one of the first with delivering data in 2026.